Working? Well, welcome to Tech Tuesday number 9. Skip these parts. Today I want to talk about what happens when you have an innovation explosion. If any of you have been keeping track of what's happening with AI, it's definitely an explosion. So generative AI is really in a boom phase. Every day something new is happening. The explosion probably started, with large language models and image generation. So it's been going on for a while. Anybody used Google Translate and liked what came out and knows that machine learning is doing useful stuff. But what probably set it off right now is ChatGPT. ChatGPT is a chat interface which allows you to talk to the large language model. And it means any non-expert can do it because we all know how to talk. And anybody in AI has probably seen at least 7 articles or lectures on problems caused by AI, like who's an inventor and who owns a copyright. And I'm not going to talk about any of those. What I do want to do today is talk about the boom aspect. Okay, from time to time, it doesn't happen often. We suddenly have a boom with suddenly an explosion in some field, and we have a client, and the client is in that field, and we're asking ourselves, what are we going to protect and what are we going to do? So what I want to do is I want to look at these booms as a stress test. Okay, the boom has particular issues because everything's exploding, but the problems that come up are the same problems we have in everyday work, except that they're really amplified and really highlighted and much more difficult to ignore when we're talking about a boom. So just to give you some numbers, I took the slide from Kaggle. And if you look down here at the bottom, you can see how quickly things are changing. Here's DALL-E, here's DALL-E 2. Okay, just a little bit later, here we have GPT-4. GPT-3 is over here. It took it 2 years to come. And GPT-5 is already in the work. ChatGPT is over here just a few months ago. And in general, you can see that there's work and it's become accelerating and accelerating and accelerating. And AI, generative AI in particular, is not just a regular breakthrough technology. It has some special bonuses which make it more interesting. First of all, this change, which is happening daily. Second, very rapid uptake. So TikTok is one of the fastest uptake in technologies in recent years. In 9 months, it got to 100 million users. ChatGPT got 100 million users in 2 months. Another bonus is it's affecting us from the top down. A lot of technologies affect, let's call them blue-collar workers or things we do at home, but generative AI is coming directly for knowledge workers like us. There's an existential fear, which is important for IP reasons because it brings in regulatory oversight, which is good for IP. People are worried that AI is going to take over the world, not only take our jobs, but take our lives as well. ChatGPT has already shown in some particular uses an acceleration of times 10 or even times 100 in what you're able to do. So I saw yesterday an example of somebody in 30 minutes, he built a complete marketing plan, including marketing emails for some ideas that he had. Okay, that is not something you do in half an hour and not something you do in 5 hours. And if you don't know how to do it, you don't even do it in a week. And of course, there's some real IP issues which are raised as well and which I'm not talking about. And here's some problems which we have in any type of IP. but we have them, especially when you have a breakthrough technology, and especially when you have one of these explosions. So the first problem is the exploitation problem. Okay, a client makes money when he is able to exploit the technology. The question is, when are we going to get to the exploitation stage? Traditionally, when you have new technology, first you try to grow, to scale, and only after you scale, you start squeezing your clients to give you money. So when are we going to get there? We don't know. There's a velocity problem. Things are changing so quickly. When we write a patent, we always ask ourselves, when will this patent be obsolete? So if you're thinking about a drug, the patent will expire long before it's obsolete, usually. When you're thinking about computer technologies, it's usually the other way around. In AI, it might be even faster. It could be that any particular innovation will be obsolete by the time we get a patent in a year or in 3 years. When we have one of these R&D firestorms where the machine itself is helping the machine get better, it becomes really difficult to identify critical features, because what appears to be a critical feature can perhaps simply be a rung in the ladder to build a new critical feature, which makes the first one unneeded. So we just don't know. And this is true, like I said, in any type of breakthrough technology. It's difficult to pinpoint what is and what isn't a critical feature. The pause problem. In an ideal world, when we write a patent, when the R&D slows down, we say, okay, now we have a disclosure, let's write an application. But if everything is changing every day, we don't have any of these stabilities. Hidden prior art. So on the one hand, a lot of stuff is published, but on the other hand, a lot is not published. And if the amount of work is doubling, assuming every 4 months, it means that 90%, or I didn't do the math, but let's say 90% or more of the prior art will not be available for another year and a half. The matching problem is hidden utility. We have no idea what is valuable now. We don't know what's going to be valuable in a few years. If we don't know what's valuable, we don't know what it is we want to protect. One of the reasons why we don't know what's valuable is because the ecosystem and the value chain don't exist yet. And if they don't exist, we can't identify leverage points where getting IP to cover that particular point will become valuable. Something particular to AI is how easy it is to copy. Stanford University published a paper how they copied the chat interface for $600. Okay, the details are not important, but since we're talking about AIs, and if you can simply copy an innovation just by talking to it, that's very difficult to protect. Most technology nowadays, perhaps not 200 years ago, we understand why it works, and we have a good idea of what the limits are and what the opportunities are. Here, we don't understand how it works, and we don't know what the limits are, and we definitely don't know what the opportunities are. And last but not least, think about the time horizon compared to how long it took internet technology to develop, mobile phones, smartphones, the steam engine. The original steam engine patent was extended by 25 years by Parliament. I shouldn't say it's the original one, but Watt's patent on the improvement on the Newcomb engine was extended by 25 years because he didn't have enough time to exploit it. Okay, we're not talking 25 years, we're talking 25 months or 25 weeks here. Okay, so generative AI is a general purpose technology. And what does that mean? These definitions that are done by economists, but I modified them a little bit. The first one, and all of these, of course, affect the type of IP that we want to get. So it's enabling technology, meaning that technology creates opportunity for many new products or fields. And as an IP person, that's bad. Why? Because if there's many new products, how will I write IP to protect all of them? So one of the ways we might do that is to identify a common critical feature in many of these products. An example of such a feature is what's called context window. At least today, the large language models have only a certain amount of information you can feed into them, be it 5,000 tokens or 40,000 tokens or even 100,000 tokens. So figuring out what to put into the context window appears to be a problem which is common to multiple products. It doesn't matter if I'm building a product that's supposed to write a patent in my style or a product that's supposed to debug software. In both cases, the amount of information I want to put in is too much, and I have to somehow slim it down for the context window. So IP on the context window could be valuable for blocking a plurality of different products. The technology is pervasive, meaning it can be used as a building block in a lot of different applications. So it's good for the technology, it's bad for us. It means that there are a lot of different interfaces between the AI technology and whatever it is that it's part of that we want to protect. There's a lot of technological dynamism, meaning that the technology is continuously improving, but not just a little bit every day. Everything around us is improving every day, but rather it's significantly improving. Okay, what you couldn't do yesterday is easy to do tomorrow, which means we don't know what's critical, but it also means that we don't know what kind of infrastructure you have or will need. To the extent that you know, I'll talk about it in the next slide. It's actually a cluster of technologies that are all developing together. So there's a chat interface, which allows anybody to use it, but it could be that it's already been superseded by other types of interfaces. There's the whole technology of large language modules. There's the underlying tech like stable diffusion, transformer, and other architectures that are being used. The very fact that there's several of them means that it's more difficult to protect. There's a whole cluster of technologies being developed even as we speak. I keep getting more notices in my mail about how to interface these AIs with some particular task done by people. I'm not talking about the chat interface. I'm talking about the interface between the AI and the task itself. And just to remind you why all of this matters, usually as a step one, we want to find places, as in the solution space, which are characterized by having potential value. Otherwise, why do it? Criticality, meaning that other people want to do it, and uniqueness, meaning that there's no other way of doing it. It's really not easy to do if tomorrow somebody can come up with a new way of doing it. And this is likely to happen if we don't even understand where the power of these new AIs is coming from. Is the power coming from the data that we put in, or is it coming from the way this data is analyzed? We don't really know. I don't even know how we can know. Okay, so I can't just leave it as a question. Here's a few guesses which might be interested. Today, reliability in the sense of what's going to come out is low. What does that mean? Large language models have a hallucination ability. They tell you something which is not connected to reality, but they pretend it actually exists. If we can identify tasks where low reliability is okay, those might be tasks which are going to be done first, And getting IP on how to do those tasks could be interesting. How to increase reliability, that's a flip side, could also be interesting. As you know, if there's a problem, solving it can be useful IP. Right now, they're solving it the hard way. Okay, so ChatGPT 4 is much less likely to hallucinate than ChatGPT 3.5. Infrastructure. You know that I like getting IP on consequences, but at this time when there's little infrastructure for doing AI, IP on interfaces and the infrastructure might be more valuable. Pain. Usually when you ask yourself, where will IP be valuable? New technology, what should we protect? So new technology is used to alleviate existing pain. Why? If somebody has a $500 million project which is stuck, they're willing to pay a lot of money to get that project unstuck. And then people usually look at current opportunities, where there's an existing market or well-known need. And only after that do people start creating a completely new market. So that would suggest that you want to first file IP on applications having to do with pain, and then on opportunity, and then on blue sky. Okay, and I give you the example of search. Solving a search problem, which is part of a huge market, is probably going to get more attention than how to make human-like avatars in the metaverse, except that yesterday I read an article about how to do that. So people are doing that too. But doing search is a huge market, and if you can solve some of the problems, like how do you advertise when your machine is so smart it gives you only one result, that's a big problem. And if you know how to solve it, it has a lot of value. And each company has a different view of, do they like having more competitors, more risk, easier time getting money, and how long until it's valuable. So there's room for everybody. And one of the things people like to do is looking for killer applications. So this is enabling technology, which means there's probably a lot of applications and some of them are critical. So perhaps even if you aim low, just look for one application, this could be valuable. So to summarize everything that I said, we don't know the limits of the technology. There's a definite risk of regulatory involvement. I've heard about some countries wanting to block it, but I'm not sure. It came out on the 1st of April, so I can't be sure yet. But there's definitely issues that AI needs to be slowed down. And if there's regulatory involvement, then you can get IP, which isn't so good, but the regulatory involvement blocks the competition from doing other solutions. We're in the middle of an explosion. Most of what people think they want to do and most of the companies are going to fail. I love reach-through IP, but we don't know where we want to reach through. I love leverage, but I don't know for who. Maybe we want to look at where there's the highest risk of alternatives, and that's where IP will be less valuable. And usually where there's pain, that's where people are going to have a lot of alternatives. And I'm reminding you that the big players can decide where there's pain because they decide to charge more money or less money, and where there's going to be alternatives. And last but not least, how fast do you need the patent? Could you do it with trade secrets? Probably not. Are you going to have a data moat? Maybe, but we're talking about technologies that specializes in taking data and compressing it into insights. So maybe a data moat won't be very valuable because other AIs will know how to steal what's valuable about it. Okay, that's what I have to say about the boom in generative AI. We don't have time, but just so you'll see, I also have completely different technology, and we're not far from this type of technology. Let's say you build a reliable fuel cell with a power to weight density of 100 kilowatts per kilogram. It's not unreasonable. And your client tells you you can file 4 patents. So what are you going to file patents on? Okay, you know that this has been the holy grail of the fuel cell technology ever since we used it to power the moon buggy in the Apollo missions. So the question is, what should you protect if suddenly you're able to have 100 kilowatts in 1 kilogram? Okay, I am stopping the recording.